Okay, so this is the review for your Chapter 2 test, which will be on Friday. So I'm going to take you through each one of these problems and show you how you need to approach them. All right, so let's look at the first one. It says use the graph to estimate the limits and value of the function or explain why the limit does not exist. So we're looking at the limit as x approaches 1 from the left. So I'm going to write 1 instead of writing on this. I'm going to write it on a sheet of paper, 1a. So I'm looking, and as it's approaching 1 from the left, the y is approaching 1. So the answer to number 1 would be 1a would be 1. On 1b, the limit as x approaches 1 from the right. So I'm coming to the right, and even though there's an open circle, that does not affect our limit. My y is approaching -2. Now c, the limit of g of x as x approaches 1. So this is from both sides, here and here. So the limit does not exist. And here's what you write. The limit as x approaches 1 from the left of g of x equals 1, which does not equal the limit as x approaches 1 from the right of g of x, which equals -2. So that's how you need to write that explanation. That is good notation, okay, as far as your reasoning. And D, g of 1, well, g is of x equals 1 is defined at 1. Okay, and then I have you looking at number 2, and it says determine by substitution the limit as x approaches -3 of 7 minus 2x minus x squared. So all you do is you substitute in a -3 where the x's are, and your limit on that one is 4. So that would be 7 plus 6 minus 9, which is 13 minus 9, which is 4. Okay, so let's look at 3. Assuming that the limit as x approaches b of f of x equals -4, and the limit of g of x as x approaches b is 8, they want us to find the limit as x approaches b of f of x minus g of x. So all you do is you strictly take the limit of f of x, which is -4. You're going to minus the limit of g of x. So your answer is -12, which is A. Now, on number 4, it says find the limit graphically. Well, let's take out your calculator. Okay, and we'll put it in the calculator here. Uh-oh, I put that in wrong. It's 3 plus x squared. All right. All right, you should get some graph looking like that. Now, you're wanting to find here's the problem, as x approaches 0. So if you're looking at x approaches 0 from the right, from the left and from the right, it's approaching 3. So your answer to number 4 is 3. Now, I'm going to see about putting it in your limit. New problem, I'm going to clear that. All right, let's put 3 plus x squared times, put your times in there, it may not work without it, 1 divided by x, comma x, comma 0. And it tells you 3, 2. So I don't care if you do it graphically or if you do it with your limit function on the home screen. Okay, so now let's look at number 5. For f of x equals absolute value 4 minus 3x over 6x plus 1, use graphs and tables to find a. The limit of f of x as x approaches positive infinity, b, Blair Witch Project there, limit as limit of f of x as x approaches negative infinity, and c, any horizontal asymptotes. Okay, so I'm going to show you this graphically first. All right, we're going to put in our absolute value brackets. I'm going to go to catalog. Y'all can probably find it another way. There's my absolute value. 4 minus 3x, close, divided by, open parentheses again, 6x plus 1. Make sure that that looks right. Okay, now I'm going to graph it. Now I'm going to tell you that this one is very tricky. If you will look right here, it actually goes down and comes back up. So you can go to your table and you can see as it goes to positive infinity, it looks like it's approaching 0, but then it comes back up, and this is kind of that sandwich theorem we talked about earlier, and it's actually approaching 0.5. Now let me go back to the graph, and I'm looking at this one, and it looks like it's approaching 0, but it's always best to look at your table. And I'm going to the negative side of things. Looks like it's approaching and I can keep on going out if I want to. In fact, I can go to my window and I can ask it to go to negative. Oh, nope, sorry, hold on. Oh, table set. I can go to negative 20. Oh, well. And you can see here that we go on out and it's still approaching negative 0.5. Now let's check to see if we could do this with our limits. Clear that. The limit, absolute value, 4 minus 3x, close, divided by parentheses, 6x plus 1, x. Now the first place we're going to go is to infinity. And remember, infinity is your green catalog. Let's see what it gives us. There's your 1/2. So you can do it on the calculator. And so I can just change this to negative infinity, and there's your negative 1/2. So you can do both of these in your limit on the home page. Now, as far as horizontal asymptotes go, they're just y equals 1/2 and y equals negative 1/2 from these limits right here. Because remember, anytime when x approaches positive infinity, if there's a limit there, those are the horizontal asymptotes, or if it goes to negative infinity. Okay, let's look at number 6, and I'll have to show you this one right here. All right, it says, consider the function f of x given below. Which of the following appears to be true about f of x? The line y equals 1/2 is a horizontal asymptote. If you'll look at the scale down here, it goes from -3 to 3, -3, -2, -1, 0, 1, 2, 3, and this is from -2 to 2. So -2, -1, 0, 1, 2. So yes, there is a horizontal asymptote at y equals 1/2. The limit as x approaches 2 is 2. I see a vertical asymptote there, so I'm going to say that one is false. The line x equals 1 is a vertical asymptote. Yes, that one is true. The limit as x is going to positive infinity is equal to the limit as x is going to negative infinity. Yes, they're both approaching that y equals 1/2. So that's true. So it says, which of the following appears to be true? Don't think about the false, but the true. So 1, 3, and 4. So your answer is D on that one. Okay, let's flip it over. And look at the back side, number 7. Find the vertical asymptotes of the graph. So I'm going to go to my y equals. I'm going to type in parentheses 3 minus x, close, divided by x squared minus 16, close. Make sure that that looks like what I need it to. And I'm going to graph it, and I'm going to have to fix my graph. I've got it zoomed in, so if you want to do zoom 6, F2 6, you can see the whole graph. And they're wanting vertical asymptotes. So one of the things is I'm seeing here, and I'm not sure what's happening here, but I can hit the trace key, F3, and I see that I am still getting x's and y's, so that's telling me that it is actually probably very close to that x-axis. So another thing that I can find for vertical asymptotes is go to the table, and I'm going to have to go, because that looked like it was somewhere around -3, -4. -4, it says that it is undefined. So that is one of them. And you need to write it like this. It's the vertical asymptote. And then there was another one. And it is at 4. So those are your vertical asymptotes. Describe the behavior. So here's what we need to do. You have to do the limit as x approaches -4 from the left. You have to do the limit as x approaches -4 from the right. You have to do the limit as x approaches 4 from the left. And you do the limit as x approaches 4 from the right. So we need to go back and look at those. Okay, now looking at these right here, as x is approaching -4 from the left, the y is approaching positive infinity. as x is approaching negative 4 from the right, the y is going to negative infinity. As x is approaching 4 from the left, y is going to positive infinity. And as x is approaching 4 from the right, y is going to negative infinity. So that's how you answer 7b. All right, and I've omitted 8. Let's look at 9, and 9's a little bit tricky. So you'll want to graph this in your calculator to find the points of discontinuity. And then we're going to describe those. So parentheses, x squared minus 3x minus 4 divided by x squared minus 7x plus 12. Okay, make sure that that looks right. All right, let's graph. Okay, so there definitely looks like there's a point of discontinuity right here, possibly at x equals 3. Let's go to our table and check that out. Here's another interesting thing. So yes, x equals 3 is a point of discontinuity. So for number 9, x equals 3. Now they wanted you to describe that. Now what I want you to look at is that x equals 3 is a vertical asymptote. All vertical asymptotes are infinite discontinuity. Okay? Now, one of the interesting things was when I looked at the table, I saw another undefined at 4, at x equals 4. But if I look at the graph, I'm not seeing any space here. Well, what that is that is known as a removable discontinuity. Basically, anytime there's a hole, and we won't see it on our calculator due to the pixels, so you're not going to see a big gaping hole here because of the way it's drawn and because of the pixels. But if you check your table and it looks like at 4 it's a continuous graph, but there's an error, and you can even see on my table I have it going up by 0.5s, so I know that there was something in between the 3 and the 4. So if you're not going up, if you're just going up by 1s, 3 to 4, you'll see undefined, undefined. But I actually have mine so that I see, yes, there's some graph, there's some part of the graph between 3 and 4, and then from 4 on, so that tells me that there is a hole. The only other type of discontinuity that we don't have here is one called jump, and that would look something like you did this, and then you did that. So where you actually jumped up, okay? That would be a jump, but those are very obvious. So let's move on to number 10. Find a value. This is another one that we have not done in class, but it's extremely easy, so I felt like I could show you, and you should be able to do it. So it says find a value of a so that the function, this piecewise function, f minus ax squared for x is less than 1 and 4 plus 3x for x is greater than or equal to 1 is continuous. So here's all that you have to do on this. So you set these two things equal because they have to come together to be continuous. They have to intersect. So in order to intersect, we set them equal. So then I'm just going to solve for what a is. Now, one of the things that I can do is you see here, these are 1s and 1s. So x is less than 1, x is greater than or equal to 1. So that is the x value that I'm going to put right here. So 5 minus a times 1 squared equals 4 plus 3 times 1. So that's 5 minus a equals 4 plus 3, which is 7. Negative a equals 2, so a equals negative 2. So that's all you have to do on problems that look like this, where I'm asking you to find a value so that this is continuous. Now, if you need to at any point in this video, stop and back up and look over it. All right, so let's look at 13. Find the average rate of change. So the important thing here is average rate of change for the function f of x equals x cubed minus x squared minus 4 over the interval negative 3, 5. Remember, this is x1 and x2. So what you want to do is you have to find a y value for each one of these. So when you plug in negative 3, so take your calculator and store negative 3 and type in x to the third minus x squared minus 4, and you get negative 40. So that's your x1, y1. At 5, I believe you get 96. That's your x2, y2. So to find the rate of change, or the slope, the average slope of this secant line, 96 minus negative 40 over 5 minus negative 3, so 17 is your answer when you do that on the calculator. These would change to pluses. All right. And then the last one, number 14. That's what we did in class on Tuesday. You have this function. You have this point 2, 13, and you want to find a, the slope of the curve. Okay, so that's where it involves the limit as h approaches 0. This is just standard. F of a plus h minus f of a over h. So we have to get our other point. So remember, if we're at a point 2, 13, and I'm going to find another point up here to find this secant line, okay, then this would be 2 plus h, and then the y would be 2 plus h squared plus 9. Okay, so this is the y value of the a plus h. So that is this part right here. This is your y. So that's going to be 2 plus h squared plus 9 minus, this is your y of just your first point, which is 13, all over h. Okay, now let's work this out. So we need to FOIL that. So that's going to be 4 plus 4h plus h squared minus 4 over h. Those cancel. So take out an h. Okay, and so that leaves the limit as h approaches 0 of 4 plus h. And when I substitute a 0 in right here for h, my limit is 4. That is also my slope. That is your answer to A. Now the other two are pretty easy. The equation of the tangent line, y minus y1 equals your slope, because that's the slope of the tangent, x minus x1, and I would leave it just like that. And then C part asks for the equation of the normal. So if this is if this is 4, then the slope of my normal, or my perpendicular, is negative 1/4. So I simply write that equation again. Y minus y1 equals negative 1/4 x minus x1, and I would leave it just like that. I would not worry about working it out. I'm not specifying that it has to be in y equals mx plus b, so that's the easiest way to leave it, and that's perfectly okay. Your test will be extremely familiar, looks similar to this, okay? And so I hope that helped to make sure that you understand how to work these problems, and I will see y'all on Tuesday.